You will definitely see.
No wonder you hated that lab. Yeah, let's talk a little bit about that. Folks, welcome to our CCNP class. A couple things I want to go over. First off, please do remember weekly to log in to our Canvas class, just so I can give you credit for logging in. Everybody pretty much has done that in this class but except for a couple. So please do that. Just once a week on Wednesday if you can. And actually, if y'all want to make it Monday, that's fine too, because we can make it Monday for your class so that we've got consistency. But just try to log in. It's easier for you because your main class site is actually the Canvas site instead of Netacad. The only thing you're doing on Netacad is taking the exams. So a couple things. Let me jump in here real quickly and talk about some stuff. I'm going to download for you. In fact, I've already got them. I don't know why I'm going to download them, but I'm going to go get and post for everyone the CCNP ENARSI instructor lab source files. So I'm going to take these lab source files right here, and I will download, actually, let's see, lab source files. So here's the lab source files, and basically the reason I'm going to give you these is because, honestly, some of these troubleshooting things are kind of nuts, but this tells you what should be done to fix it. So the first one was going in and getting rid of the wrong default router and putting in the correct default router. The second one then was literally changing the helper address, putting a helper address on it. They had the wrong helper address, put the correct helper address on it. And in fact, they just had the helper address on the wrong interface and they had the wrong helper address. And then this one made no sense at all because you could ping everything and had full connectivity. So the only way you know that this is what the error was is because you were not getting a DNS name via IPv6 and you were not getting an IPv6 DNS address from that pool. But let me show you how these are supposed to work, just to kind of make life a little bit easier on you. So if you are, let me grab this over here. I'm going to grab this, start the download. So I'll have these for you. I'll post these right here under labs. So under the NetLabs doc will be the, in fact, I'm going to do it right now. I'm going to just drag it over so you'll have it. Just let me grab this while I'm sitting here and thinking about it. That way I can't have a senior moment and forget it. My excuse is I've been hit by a truck and I'm sticking to it, which I was actually hit by a truck in 2016 and paralyzed from the neck down. So most of y'all know that. I want to upload it. I do not want to, oh, it's already there. So let's just replace it. So I got the newest one. All right, so home. I'm going to place right here the file, which is the instructor documents, instructor lab source files. Okay. So add this, and I'm gonna drag it up from down here up to be at the top of the lab. So if
Kelly, I think they're already in there.
Are they?
Yeah, if you scroll all the way up.
Oh,
right
yep,
there.
Sure are. Okay.
Yep.
I did have them in here. Well, let's do this. I'm gonna remove these just so I'm connected to the correct one. And I'll leave it down here so it's closer to the lab so you can see them if that's okay. But you can look in here if you're doing the troubleshooting labs and you're lost and don't know what's going on, go look in there and they'll tell you, okay? Now, here's the other thing. On these most of the troubleshooting labs, when you go in here to do your lab, if you do the lab and schedule it, and I have to give it a couple minutes to get started here, it's going to boot up, but each one of these labs actually has inside of it, it loads a bunch of tickle scripts or TCL scripts. And those scripts have configs that are already there for you. And so you don't have to type in everything for the troubleshooting. Now, there are some of them you do have to type stuff in, all right? But the troubleshooting labs, you actually have tickets that you place in and you tell it what to do. So as soon as this gets up and running, I'll show it to you. But basically, when you go in to do this very first lab, the devices will boot up. They'll be completely clear. There'll be nothing on them. And then you are going to go into the iOS and you're going to copy from Flash the trouble tickets. Okay. So once you do that and get all three of them loaded on each one of these, it's ready for you to start troubleshooting. So like it says here, PC1 is unable to access the resources on this web server. Fix it. And then it says PC1 and 2 are unable to access this. Fix it. And then this one says PC1 and 2 are unable to drive IP addresses as host names. Upon investigation, appears they're not receiving DNS. So even that you see that, that leads you towards it, but it's still kind of crazy when you copy it in there. If you don't pay really close attention to these, you're not going to understand what it's asking for and why you missed it. Okay. So this is literally, it's already got a DHCP server, but it's a stateless DHCP6 server. And so you go in here and you can fix that. So I'll be honest with you, I missed this the first couple times I did this lab. I just completely missed that scenario because I just started down here and looked for it and said, well, what am I supposed to do? These were fairly easy to find because I could tell they weren't getting an IP address because they got a 169.254 number. And then up here, I knew I couldn't ping anything. And so and honestly, I saw that one as I was loading the configs in. When I started looking around, I was like, well, I see what's wrong with this. I mean, you know, all you had to do is go and look at the DHCP pool and you immediately go, that's not the right default gateway. But they are going to tell you what's supposed to be wrong and then you fix it. You don't have to type anything in other than loading these configs from inside of here. All right, so you don't have to type in everything on this one. Is that the one
That
you're
is so great. Yes, I was doing that. So I saw the script, it loaded the script,
Right,
like the very first one.
right.
And so I was like, okay, but I didn't restart it. That was my
Right.
fault.
So what you
I
do
didn't
is
even think about it.
yeah, when you get done with this one, you actually have to go through and write. And you notice what it's doing here. It asks you to do a banner message of the day when you fix it, and then save the config. Because then I can look through NetLabs and I can actually just do a Control F and look for ticket 1112 or 1121. Pop, I'll see your config, and I can do that. But then you go in and do this reset now, and that actually erases everything and reboots it. And then you go down here to the next trouble ticket. You load the new ones. But I'm like you, Brian. I mean, literally, it takes more time to reload than it does to find the problem and fix it. So I don't know why they didn't just combine these two together and say it can't get the web resources, and you know, you're not able to get and you would have fixed it easily. So I don't know. I don't know why they didn't do those together. But on the troubleshooting, by the way, you will notice I had a good question from one of your co-students that said the what is this here? See what you got. That said something like, yep, there they are. Okay. That said something like, what do I do? What do I upload when I get done with this lab? Well, obviously, there are no questions in here really for you to answer. So all you need to do is just save this document, the one from inside of here, because here's our NetLabs document. Save it with your name and upload it here for this upload. And that just tells me you finished the lab. I need to go check it. All right. Now, if it does have questions, please answer the questions and upload that in the document also. And also, if it doesn't, for instance, it's a lab that has configs that you need to do, so it's not a troubleshooting lab. If you want, it's optional, but you can just drop your configs at the end of your document. Just do a Control A and Control C, Control V, and paste them in. Control C, Control V at the end of the document. I can see them. That's one of the awesome things about NetLabs. And I'm gonna, Brian, do you mind if I show one of your labs? Actually, I can show my own lab. I did a lab earlier today, so I can actually go in here and I can pull up inside of our class. I did a lab. I did the first lab again. So here's my reservation today. But I can actually go into devices and I can look at final configs and I can also look at logs. So I can go in here and go Control F, fixed. Okay. Fix ticket 111. And so I can go up here and say, all right, what did they do to fix it? Okay. So this is my banner message today, do right. And I'll go up and see, all right, what did I do to fix it here? So we did that's a trouble ticket. Start config. So I can find show IP in brief. I did all those. Yeah, it took me about 2 seconds to fix it. And I went in here. Or I didn't fix that one. I don't know what I did there. But either way, I can do fixed, and I actually can find each one of my tickets. Oh, there it is where I fixed 2.1. There's the helper address I put in. So I see that I fixed ticket 2. I know I fixed ticket 1. I don't know if I didn't save it right or what, but I know I fixed it. Let me go up here and find it. The different config. Let me see. By the way, that's just the TCL script dropping that config in. If you've never used TCL, it's a pretty cool little language. It's a scripting language that can be used on Cisco devices. I must have cheated and didn't do this one, but I know it did. I changed it. Oh, it's on the other router. I'm a doofus. Okay. So it's on R2. That's why I'm a doofus. Because I forgot to. Okay, let's go down now. There. I changed the default router to 10.10.10.10.10.1. Now, I actually didn't remove it from, let's see, yeah, they had 10.10.10.254, so I took that off and put 10.10.10.1. So I fixed it on R2 where the problem was, and then again, here's the fixed ticket 122. And so each one of these, as you're doing the lab, it asks you to, during your lab itself, it says, okay, now when you fix this issue, create a banner message of the day, copy and save it, and then do the reload or do the reset. And that's this reset right here is what erases everything and sets it back to a blank router or blank switch. And then you can go and do your next troubleshooting. But that way, if you don't do that, if you just load them on top of each other, you're just going to continually load problems on top of it. And they don't always build on each other too. So it could be a different scenario completely based upon the trouble ticket. All right. So does that make sense? Okay. So with the trouble tickets, just put your name on it and upload it here. If it's a actual config lab, so let's say it's a lab. Let's go in and look at another lab. Let's look at.
Well, that second lab, the static routing lab, was just as bad. I stopped doing it about 10 minutes in.
I don't disagree with you completely. Yeah, there's the static, that one, some of that one's a little bad. But like this one here, implement EIGRP. Actually, I'm gonna go back and just pull the lab up itself. By the way, you can always go in here and look at the lab, preview the lab. But this one's implement EIGRP. So this is just a configuration. So this is gonna have you, and you can copy and paste these in. You don't have to type that in. So don't sit around and just copy and paste it into NetLabs. Don't type all that stuff in. Go config T, copy this, dump it in when you're in there. But when you get done with this one, if you don't mind, it would be nice if you could just, when you upload the document, at the end of it, just put your configs at the end. And here's why I'm asking you to do this. I have now been asked twice, well, more than that. Those of you who are not familiar with continuing education credits, I want to show you something about continuing education credits. And this is going to take away some of our time from being able to do lecture today, but I still want to show you this because it's very, very important. Let me find my document here. Okay, so one of the things that now takes place, if you need to renew your CCNA, there's a couple ways you can do that. One is obviously you can take your CCNA again or something higher. So if you take CCNP Encore and pass it, which I did a year ago, it renewed my CCNA. You also can actually renew your CCNA and other certifications with CE credits from the Academy. This particular course here, if you're trying to renew your associate, it takes 30 credits per year, or 30 credits to renew it. If you want to renew your specialist, it takes 40 credits, professional 80, other CCIE on up to 120. All right. Here are the courses that you can earn credits on. You can earn 40 credits for successfully completing this course. But you also notice that the only thing so if you want to renew your CCNA, let's say your CCNA is due next year, successfully complete this course, you can apply to have your CCNA renewed, and it'll be renewed for the next 3 years. Okay, if you successfully complete this class. But you'll notice the only thing we're uploading on netacad.com are our exams. That's it, nothing else. So when you apply for these CEs, what happens is NetAcad support emails me and says, you are the instructor of record. Did they do anything else? Did they do hands-on labs? I pull from NetLabs your information that says all the labs you completed. Remember, you've got to do at least 25 labs in NetLabs. That's what's required. And then I send it to support. And that way I can say, support, they did these labs. Now, if for some reason they ever question me even further, if I've got the documents that I can just send them your documents that you uploaded, that would be an additional thing for me to be able to do. So I'm just trying to get away for us to CYA. cover all our rear ends. But I'll send everyone this document in the class because it's actually, you go to ce.cisco.com when you finish the class, tell what class you did, what kind of training it was, and then it goes on through and tells you has to be submitted within 90 days of your course completion, and then you will get credit. Now I think, Brian, you got credit for the last class, didn't you? Or did you put it in there? Did anybody in the last class get credit? I know there were several because Bernard just got it.
Yeah, I got my credit. It actually didn't take very long after the class actually finished and I applied for it. It was pretty quickly.
Yeah, and what I actually did with that class, and I'm surprised Bernard I had to get them to send me anything because I preemptively sent into support. I said, here's a list of people who just finished my CCNP Encore course. I have all the records of the labs they've completed. So I actually sent in a preemptive thing, but evidently that got lost or they didn't check it. So I had to do it for another student. But this is an awesome benefit of taking this class and passing it. So just take this class and pass it, and you can renew your CCNA by using this method. All right. But that's why I'm asking you to upload these things. And that's also why inside of NetLabs, it's really good, because what I end up doing is I go in here and literally I'll go usage, labs, and then I would sit and go to the class itself. And I do something like this. So let's say it's, I'm just going to put my name in here because it say Caudle, C-A-U-D, and I would just say, okay, Kelly did 2 labs. Actually, I'd say in this case, they did 2 labs, but it was the same lab. But you'll notice I've done 1.12 hours worth of labs. All right. So they're looking for around 25 to 30 hours worth of hands-on labs minimum. So that's why I make you do 25 labs, which will probably be at least an hour or more piece. So you'll get 25 to 30 hours worth of labs. So, and it's hard for them to argue with that when I can sit down and say, this last student did 41 labs, 36 of them were unique, and they did 43 hours worth of labs. You can't argue with hands-on there. So, and that also, Shandy, is why we don't want just using Packet Tracer, because I can't track that. I can track this, and I can say they were in this. Now, of course, you could just log in and I look at them to make sure you do the labs, but you may not actually take 3 hours to do a lab. It may only take an hour and a half, and you forget to log out. But still, you do the labs, so I know you at least did the labs. So that's why it's very important that you do that for me. Questions on that? Questions on how we're dealing with any kind of uploads here? Okay.
Hey, Kelly, can I point out something?
Yeah, go ahead.
So I've done the first 3 labs, and the third one, like you said, has got copy and paste commands to be put into it.
Right.
And I'm used to Cisco screwing up their documents like nobody's business.
Yep.
You can't copy and paste those because some of the commands are on 2 different lines. So the only way you can do it is put it in Notepad, fix it, and then paste it back in.
Yep. And let's see, I don't think I've got these done yet. I did for all my first class for Encore. I've actually got all the configs out and done, fixed for you. Let me see if I got NRC. Nope, I don't have that done. Well, wait a minute, hold on. I may have forgot to put these in there for you. If I did, I don't think I have them finished. It was on my list of to-dos that didn't get done. Nope, I got lab 212 and lab 21312. I will try my best to get these done for you. I actually went in and copied all those out and just fixed them in my Encore class. But you are correct. You do have to take them out and put them into a Word document and fix them. So just be aware of that. You can't directly, if it splits a page, you can't directly copy it in.
So all those mistakes you see, it's not on me.
I got you. I got you. No, and you'll know very quickly when you paste it in, because it'll go about halfway through and then dial, and you're like, ah. Yep. So I'll try to get those finished. Like I said, I've got 212 and 312 where I've actually gone in and here's what I did. I just went in and I went in and created the like D1. Here's the text for it straight out of the document. So I just paste them in, and so I hadn't got that finished. So I'll put that on my to-do list to get to done. But I do want to show real quickly here. Again, remember you're going in and come on, Pod. NetLabs burped on me today. It gave me had a like a 20-second thing when it dropped me out. So copy flash : ENARSI, and then you'll notice in here 1.1.1 2.1 I think is what it is, and then to run, and then do that, and then you do each. So when you're doing the first trouble ticket, this will be 1121. So you're seeing you're putting in 1121, and you do that on each one of these. So copy flash : remember the tab because it is your friend. 1.121 tab to run, and hit enter, and then copy flash : ENARSI 1.1.1 2.1 2.1 boop, run, and now you're actually ready to do the lab. So, and what I usually do is I do a show IP int brief just to make sure the interfaces did come up, make sure everything's hunky-dory. So all the interfaces are up. Do the same thing over here. And then again, I did do a show VLAN over here because I wasn't absolutely sure what VLAN it was supposed to be in, but it's VLAN 10. Okay. And then over here, obviously, it's asking us for these things. And I just went in here. By the way, if it's blurry, click here and do show actual size, and it will clear it up for you. Let's see here. And remember, it's going to be the bridge interface that's supposed to be getting the IP address, not the Ethernet adapter. It's always the bridge interface in CCNP class. We've got an IP address, 10.10.10.102, but if you try to ping anywhere, it's going to fail, and it's because the default gateway is 10.10.10.254. And if you look at the content, you can easily see that the default gateway of G001 is 10.10.10.1. So you get done with it, you go in, say you fixed it, do banner message of the day, and then when you're done, you just type reset now. And that's a really cool script that goes in and deletes everything. That, by the way, is a cool script to pull out and use in your labs if you ever need it. Because it'll go through, if you got that script loaded into Flash on all your devices, you can get into config mode or get into privilege exec mode, type reset.now, and you can easily reload your labs in a hurry. So it's just a little tickle script that goes in and erases start, and on switches, it deletes the VLAN.dat. So, okay. Any other questions on labs and those items? Yeah. All righty. I'm going to end this reservation just so it's not sitting out there taking space. We do only have 3 CCNP pods, so I do apologize about that, but that's at this moment what we've got. I will send that out to everybody. Actually, it's in this class, I believe. I think it's at the top. Should be at the top. If not, I'll just put it at the top. Yeah, it's up here. CE credit. So you've already got it right here. So just take a look at that. It really will not apply till the class ends, but then you can apply to get your CE credits and renew your CCNA or other certifications. I think you have to pick the one you want it to renew, but it should only renew, this should only renew CCNA route switch. So, okay. Other questions? All right, well, let's jump in. I'm just going to jump quickly into module 1. I'm not going to spend a lot of time here in this module because, quite honestly, this is things you should pretty much already know. It's talking about all about IPv4 addressing, IPv6 addressing. Big things here, DHCP. Everybody knows that a PC takes its IP address, adds it to its subnet mask to find what network it's on. It then takes its the destination address, adds it to its configured subnet mask to find out what network that is on. If they don't match, it then sends it to the default gateway. If it does match, it's going to go to the ARP table to see if it knows what the MAC address is to create a frame. If it does not, it will then do an ARP request and go forth and send it. Pretty simple here. Just remember, really, PCs are stupid. They only know ones and zeros. They are not extremely smart devices. And again, this is just showing what happens if you have the wrong subnet mask configured on a PC. It can think it's on the wrong network and try to send something or not send something locally when something is local, or vice versa. So now what happens in the routing table if you do a lookup and no route exists and no default gateway is configured. So there's no route in the route table to the network, and there's no route that is default gateway or
It's going to drop
default
that
route.
packet.
It gets dropped, doesn't it? Yep, it goes to the bit bucket. Goes in the bit bucket. All right. We also used to always teach about recursive lookups and all this stuff. None of that happens anymore. We've got Ceph. So we'll talk about Cisco Express Forwarding here in just a second. I teach the DHCP by talking about good old Aunt Dora, D-O-R-A, or Dora the Explorer, one of the two, your choice. But discover, offer, request, acknowledgement, 4 steps. And troubleshooting DHCP, 99% of the time it is you are not using a relay agent, or I've also seen you've mistyped the network in the subnet of the pool. It doesn't match the actual the network you're trying to hand out. It'll never hand it out. That drives you nuts, because if you just missed it by like one thing. So for instance, let me find my notepad. I use a really high-tech item when I lecture called a notepad. I would write it on a whiteboard, and I do sometimes, but my handwriting is atrocious. But imagine you did a 10-10-10 pool, and the actual network interface is 10.10.10.0/24. It's never going to hand IP addresses out of that pool, because that pool is not on that interface. Okay, so you see that on occasion. It's typically fat fingering something inside the pool, or you fat finger the default gateway, the DNS, or one of those scope options that are out there. Quite honestly, if you're running DHCP on a Cisco device in a production environment, it better be on a remote site. Otherwise, I would be running it on a Windows server, because it's just so much easier to deal with. You know, when you're actually creating pools, creating all those things, and creating pools, you know, back in the old days, we used to talk about how you should have a pool that had 70% of your addresses on this DHCP server, and then 30% on this DHCP server, so that if this one went down, this one could still, you know, there's all kind of ways of doing that with Windows. We teach how to do pools on Cisco devices, but I don't really think it makes a whole lot of sense. This makes more sense. Have a server that's an actual DHCP server running typically a Windows operating or a Linux operating system, either one, but just a server-based DHCP server or servers. Because you can have multiples if you need them to service one another.
I have a question real quick.
Shoot.
So this is probably from a different class that I've missed. But the IP helper address, when you put that in, I know that it will relay DHCP like messages across, but also it says that it can do all of the rest. Do I have to do something different than just put an IP helper in the IP? For the other things?
Oh, you talk about all, well, here's the other things it sends. It sends all these things here, which is not necessarily a good thing. The helper address will relay TFTP, DNS, NetBIOS, BootP, which BootP is DHCP. All of these actually get sent by the IP helper address. Now, the only thing you'd have to do on the otherwise is make sure there'd be a TFTP server running here, okay? Or the reason this has been somewhat of a problem is, what if you only wanted to send DHCP? There is a command, and now I've had limited success with this command, even though it is in the iOS and it's supposed to work all the time. But that command, there it is. It's called IP DHCP -server, and then whatever the IP address is. So x dot, oh crap, x.x.x.x. So that's the correct, you know, there is that command there. Now, technically, that is supposed to only send BootP, none of the other items. If I was running a super secure environment, that's the one I would use. Okay, but here's one thing you got to realize. Many times the same helper address is used by our IP phones, because our TFTP server for our phones are sitting, we try to make them sit at the same place as this helper address here. Not always, because we can do other things with that. But just be aware, if you do this, you're not just forwarding BootP. you're forwarding all of these items here, which is to me a little bit of a security hole. I prefer the DHCP server, but like I said, I've had mixed results with this one. Okay, it's supposed to be in the iOS and it's supposed to work. Doesn't seem to always work. So be aware that you're probably going to see in most books to use the helper address. Here's all of our message types. Did that answer the question, Shane? I feel like I didn't answer it, but did that answer it?
Yes, it did somewhat answer it. Yeah, I was just wondering if, so I wasn't sure if the IP helper address did all of these things automatically.
No. You've still got to have, like, you would have to have your DHCP pool sitting over there. You would have to have your TACAS server sitting on. All of these things would have the only thing the helper address does is literally take this incoming broadcast, convert it to a unicast, and send it over to that next IP address.
Okay.
That's all it does. It's literally like a gateway between, it's a broadcast that needs to be sent somewhere that broadcast can't be sent. So it converts it to a unicast and sends it over to that IP address.
Okay.
And so if you don't have a TFTP server running here and a broadcast for a TFTP server comes and it goes to 10.1.1.2, it's just going to ignore it. It's just going to, drop it because it has no way to respond because there's no TFTP server running on 10.1.1.2. Likewise, if a DHCP discover packet comes in, which is the boot P, and there's no DHCP pool on 10.1.1.2, it's never going to send back an offer. It'll sit there and never send anything back because there's no server sitting there. So all the helper address does is say, hey, take these incoming broadcasts and forward them over to this other machine as a unicast because we can't send broadcasts across routers. That's its whole purpose. Okay. Here we see a pool. Okay, so we excluded our addresses first. Here's our pool. Here's our DNS server, our NetBIOS name server, which almost nobody uses a NetBIOS name server anymore. But that's 044. That might be 046 scope type. But this is, each one of these has a different actual scope number. This is 003 in the old Microsoft world. This is 006. This is 044, I believe, or maybe 046. I think it's 044. But we don't use NetBIOS name servers anymore, really. Big issues with DHCP is not forwarding those broadcasts. That's a huge one. We had this one right here. Let me tell you about a really weird DHCP problem we had one time. We had record enrollment one semester, just crazy. And trust me, it's not recently. I wish it was. Record enrollment. All of a sudden, you'd walk into a classroom and one machine would be able to get on the network and the one beside it couldn't get an IP address to get on the network. And then 30 minutes later, the one that couldn't get on the network could get on the network and the other one couldn't. We could not figure out for the life of us what was going on. We ended up figuring out that we had a pool of addresses that were being handed out for, well, it's two problems. One, it was on the wireless network to begin with. And of course, the DHCP pool was running out of addresses because we had the default. Anybody know what the default lease time is on a Windows server for DHCP addresses? Or what it used to be anyway? Anybody remember that?
I mean, I could guess. I don't know.
Is it 7 days?
You're very close. It was 8 days. Used to be 8 days. Okay. Well, the problem is with our wireless network, we were not putting enough IP addresses into that pool with the record number of students we had. They were keeping the addresses for 8 days. It ran out of addresses. So we had to go back into that pool and literally set a 4-hour or a 2-hour lease duration so that those addresses would flush out quicker. And so that's something that can happen. So be careful in your lease how long you set your lease times to. In your classrooms, many times you can set it to pretty high numbers. I think now we actually use in our classrooms 12 days because each one of our classrooms has like 25 machines in it and 254 addresses for the classroom. So it's not a big deal that DHCP leases are very long. In an environment where they need to be quickly rotating through, like a wireless environment or even a kiosk environment or an open Wi-Fi, be careful how long you set those lease times or lease durations to. Okay. Duplicate IP addresses doesn't happen as often as you think unless you accidentally don't set aside or exclude the addresses. That's usually just a configuration error on your part. You didn't set aside the correct addresses. Or that's also why we always tell people to do this first, by the way, folks. Exclude first, because as soon as you make a pool, it starts handing addresses out. So if you don't want 1 through 10 to be handed out, you better have them excluded before you fire it up. Otherwise, it's going to use it. So be careful with that. Always teach your students to exclude first, then create their pools. Otherwise, you can end up with duplicate addresses. The pool nature of DHCP, one of the things I do tell people, if you ever have your DHCP server die on you, just don't turn your machines off. Because you've got, however your lease duration is, you've got that number of days to get it fixed. So if you've got an 8-day lease, you got 8 days to get it fixed. And the way Windows machines work is they try to renew at 1/2 of their lease duration. Then they try to renew at, I think it's 66% of their lease. And then from there, 1/3 of that number all the way down to they kick the number out when the lease expires. Okay. Here's a couple of troubleshooting commands. I don't use this one very often, but it's a good one. Show IP DHCP conflict. So there happens to be a duplicate. It could tell you that it's seeing a duplicate. Debug IP DHCP server events. Be very careful with debug commands, folks. I don't never, ever, ever, ever put debug all on a production environment. Never, because it can actually lock your routers up. Because if you debug all on a very busy device, you can actually run the CPU out of well, basically cycles, because it's going to be trying to debug and it'll kill itself. Yeah, turn off, turn it back on to fix it. That's a bad day, trust me. So don't use debug all. And when you're debugging, try to debug to the most specific events you can debug. This is pretty specific here. Debug IP DHCP server events. It tries to show you the discoveries, tries to show you what's going on. Debug IP DHCP server packet, which is showing the actual packets coming in. If you're getting this deep in the weeds, you've got some pretty serious problems going on. I've fixed a lot of DHCP problems, and rarely ever did I even have to go to debug. Most time I can do show IP DHCP bindings, show IP DHCP conflicts and statistics, and I can fix it with those. Just be aware it's there if you need it. Because I use a lot of Wireshark. If I'm doing this, I'll see if discoverers are coming out and if offers are coming back. So I have Wireshark. I use that a lot of times instead of trying to do the debug on this. But this could be useful, especially if you were on a router that is upstream and it's supposed to be getting relayed information to it. If you're not seeing those discoverers coming relayed in from those sides, you know where your relay agent's not set, because the relay agent has to be set at the interface that the broadcast will be coming in on. Okay. Now, any questions on DHCP? It is a fundamental thing that's on all of our networks. So it's a very important thing that we understand and know how to troubleshoot. IPv6 addressing. Now, we hopefully don't need a big review on this, but remember, 128-bit addresses consist of a network portion and a host portion. Typically, the first 48 bits are considered the global portion. Then we have a subnetwork prefix, which are 16 bits in that first 64. Subnetting is super easy because it's literally subnet 0 through 65.536. And that's it. So subnetting is super simple. Now, it is actually possible to go into the /48 portion and do some subnetting. You also can hit yourself in the knee with a hammer if you want to. Don't do that. It's just it's a lot of work. And unless you're at an ISP that's literally, for whatever reason, trying to subnet up in that /48, the actual standard is that we're going to give everybody a /48, and then they're going to have 65,536 subnets at their house. That's what they're saying. That's actually out there in the standard. So Be aware, does anybody remember the different ways of getting an IPv6 address? Why is that not coming up? Let me see. See if I can get my whiteboard going. Can anybody remember the different ways of getting an IPv6? Well,
Yeah.
There's a
So
couple.
Slack with stateless DHCP and stateful DHCP. So full blown DHCP v6.
Okay, let's if I can ever get this thing going up here, I'll show you how bad my handwriting truly is. Okay, so first off, we don't forget we do have another method, static. Okay, so you can actually statically assign an IPv6 address. That's possible. Then we have Slack, so stateless address auto configuration. Okay, and then we have stateless, which is it's actually Slack with stateless DHCP. Yeah, and my handwriting truly is this. I'm left-handed, so sorry, got to live with it. And then we got full stateful DHCP. Stateful DHCP. Good gracious, that's horrible. That's bad even for me. So stateful DHCP. So we've got a DHCP server. And basically what happens is with static, we assign it. With Slack, it sends out a router discovery or neighbor discovery. It says, hey, are there any routers out there with a prefix? The router sends back a global prefix. And then the host puts it on there, and also the host will get its default router or default gateway from that information. Typically, it could be a link local address or it could be a global address. Typically, it's link local. Slack with stateless DHCP, it sends out a thing that says, hey, I'm trying to get a IPv6 address. It gets back information, says, well, I've got a prefix for you, all right? But I've also got some more information. You need to go out here to this stateless DHCP to get your information about DNS, domain name, and any other options. And so it has information in the other, neighbor discovery other, which says, go out here and go find this stateless DHCP. And then with stateful, I send out Slack, and the router will actually say, hey, I'd love to help you, but I can't go up to this stateful DHCP server and get your information. So that's the three main automatic ways and the one static way we can get an IP address using IPv6. This is something that you will see mainly in labs now, not anymore in the real world. And that is EUI64. It used to be when you wanted to find the host portion of an IPv6 address from auto configuration. You took your MAC address, you split it, you put FFFE in the middle, and you flip the 7th bit from the left. And don't ask me why they flipped it, other than it actually was just to make sure that it was unique. The problem with that is you could be tracked, because all you had to do was reverse this process, and they had your MAC address, and they could track you down exactly where you were at. So almost all operating systems now no longer use EUI64. They use random or randomly generated host portions for the IPv6 address via Slack. Just note, if you do see in the middle of an IPv6 FFFE, it might be that it was generated by EUI64. Okay, Brian, what you got?
Yeah, the sad thing is that Cisco still uses it.
I know. Isn't that crazy? Yeah.
Well, I think Mac OS does too.
Yeah.
Yeah.
You say the Mac OS still uses it?
Yeah, I think the last time I checked, Mac OS still was using it.
Well, I know for a fact Microsoft doesn't. Microsoft has done away with that in their operating system. I got so tickled. One of my other coworkers was doing a video, and he's trying to blur out his MAC address on his PC in his office, and I'm like, dude, really? It'd be good. It's all good. Not gonna hurt you. No, see, we're just getting a random, and this is FE80. So this is the link local address. So I'm just doing link local. There's no global, but still I am generating this percent preferred, by the way, that actually just tells you what interface it's associated with. So each one of those is representative of an interface. If you ever wonder what that means, it's binding to an interface in the Windows operating system. But you'll see none of these use FFFE. So I guarantee you they are not EUI 64. What you got, Brian?
Nothing. Sorry, I forgot to click off.
Oh, okay. Not a problem. So that's a little weird. So again, we've got Slack, stateful DHCP, and stateless. So address auto config, that would be Slack if you wanted to do it on a router interface. For some reason, you didn't want to statically set an IPv6 address on a router. So you want it to set up to be Slack. You just do this, address auto config. It will send router solicitation messages. It'll get a router advertisement. Those router advertisements will then allow it to grab a global unique address and then use EUI 64, which is nuts. It should not be doing that, to give itself an IP address. You do have to have this. You do have to have IPv6 unicast routing turned on. So if you get a situation where you've got IPv6 configured on everything, but Slack's not working, check to see if unicast routing is on. Otherwise, it will not respond with router advertisements. So make sure that is on. Stateful DHCP, this is where you've created a pool, and you'll see that we put on the interface that the router discovery comes in, the command IPv6 ND managed config flag, and that will tell it to go find, it's got to go find a DHCP server, and you actually will tell it what the server is, what the pool is, and it will go and find that. The other thing you've got to do, if you want it to do stateless DHCP, the only thing you change here is you put the ND other flag instead of managed. So if you do nothing, you get Slack. If you put other, it's stateless. If you do managed, it's stateful. So here's the flag for ND other for stateless. All right. So a lot of that, most of that's a review of what we've done before. DHCP does have a 4-step process: solicit, advertise, request, reply, which is similar. It's not exact, but it's very similar. And there is actually a DHCP v6 relay agent. So if you need to relay to your DHCP server, so your DHCP v6 server doesn't have to be on the local router. It can be on a remote router. Okay, be aware of that. Now, I want to go through this real quickly. I'm not going to spend a lot of time in the packet forwarding process because I feel like you should know that. I do want to hit one thing here, and that is this 2 main Ceph structures. So we've got 2 different things here and how the Ceph structure is created. And that is we take our IP routing table and we take our adjacency, or we take our ARP table, and we create a Ceph table. Now, this Ceph adjacency table in 40 information base, one contains the layer 3 information. So it's similar to the information found in the routing table. And remember what Ceph is. There's 3 different ways that we can do lookups in our route table. One of them is process switched, which is every single packet that comes in, you have to go to the route table and look it up. Okay. Then we've got, oh God, I'm drawing a blank, y'all. What's the next one? Is it fast switching? No, yeah. Is that it? No, it's process switch, then it's fast switch. And then that one is, we'll do one lookup, then we'll store it and use that for all next lookups. And then we've got Ceph. And with Ceph, we do all of these lookups first and build a table. So technically, we really don't even have to do a lookup. It's all sitting in a very fast table that we can use. That is the SFIB and adjacency table that lets you create the routing information and the ingress and egress ports for this information. Now, sometimes when you go to look at a particular destination, you can do a show IP route and do it the actual IP address and see how that particular network has been learned. But this is something you want to kind of keep in your back pocket too, and it's this one right here. Show IP Ceph and then the IP address you're going to, because it will tell you where this network is and how you get to it, and if it has a valid cached adjacency. So you'll see this tells me that in the Ceph table, there's a valid adjacency for the 192.168 1.0 network to get to it and how I get to it. So this tells me I go over to 192.168.0.11 out fast Ethernet 00, be able to get there. If you ever want to see the exact route, you can do a show IPsef exact route from here to here, and this will tell you exactly how I get from 10.222 to 192.168.1.11. And it will show you that right there. This you really need to get into when you've got weird things going on in your routing. For some reason, your routing table is not working the way you want it to, or for some reason, something's not going into the routing table. You can kind of start looking in the CEF table and making sure that any changes did get into it, or maybe the CEF table is out of date, which should not happen, but weird things happen on routers. Check your ARP cache. Again, that could be something, especially because the ARP cache doesn't, I think it's every 4 hours, a Cisco router dumps its ARP cache and replaces the information in it. So if it needs to, you may actually have to age out entries on an ARP cache. Rarely do you have to do this, but it's something that's possible there. And then the show adjacency detail command will let you see the adjacencies that you have. The CEF information used to construct that next hop inside of the CEF table. So this is digging into the weeds on how the CEF table is made. Typically, if we're getting this deep into the weeds, something has gone pretty massively wrong. And it could be that we've done something in our routing protocol configuration or in our routing information to cause incorrect information to get into the CEF table. We usually have done it to ourselves, quite honestly. Last but not least, I don't want to take too much time on it, but you need to know administrative distance. You also need to know that administrative distance is the trustworthiness of a routing source. So that is why EIGRP is 90 and OSPF is 110, because this is Cisco's administrative distance. So they consider EIGRP a better route source than OSPF. Other people may not believe that. They may think that OSPF is a better route source. So AD is a Cisco concept. Right. And the rest of this, I'm just going, y'all can do this stuff, the proxy ARP and everything. Okay, any questions? Y'all will give me just a second. Sorry about that. Now, everybody, I do want to mention something. While we're in lectures like this, I have a no BS rule, or a BS rule. If I say something and many of you have been in the industry more than I have. I've been doing teaching for 28 years, but if I say something that's total BS, call it out. I've been doing this long enough to know that I don't know everything. And if anybody ever tells you they know everything, you better run from them as fast as you can run from them, because they're an idiot. So if I say something that is incorrect, bring it up. Just say, hey, actually, in real world, this is what we do. Because some of this stuff I have not worked on in an ISP environment and those types of things. So I am not above being told that I did something wrong or something's incorrect that I've said. So just make sure if there's anything you can add, any stories you have, bring it up, because the more we learn, the better off we are, no doubt. Okay. So I'm going to stop with that. Are there any questions about the class or anything in general that you need me to settle for you? I will, this recording, I will convert it to a MP4 and I put it directly on YouTube, and there's a playlist there called Spring 24 ITC classes, but I'll also email it out to everyone. So if for some reason you want to go back and look it over and see what you missed, it'll be there. It's also in that playlist, so just be aware it's there. So you're welcome to go back and review it. Those who are here obviously were here, but if not, anybody who wasn't here, they're required to review it to be able to watch it. So, all right, I'm gonna stop